Week 1 Advanced Database Systems. Course Objectives. In this presentation, you will learn how to differentiate between data and information, explore what a database is, the various types of databases, and why they are valuable assets for decision making. Investigate the importance of database design. Data are words and numbers that have not been processed and remain in their raw form. After data has been processed and organized into a more meaningful form, it becomes information. For example, a worksheet of individual sales is data. Once the sales are totaled for the month and summarized by sales region and placed into a pie chart, the data has been transformed into information. Information can then be used by stakeholders for decision making. A database is a shared, integrated computer structure that stores a collection of end-user data and metadata. End-user data are raw facts of interest to the end user, and metadata is data about the data, how the data is integrated, how the data is managed, characteristics about the data, and characteristics about the relationships of the data. A fundamental component of a database is a field. A field is a single item of data, such as a last name, a serial number, a price, or a purchase date. When related fields are combined to form a complete row of data, they become a record. A record is a collection of related fields. An example of a record would be one address record containing the fields of first name, last name, street address, city, state, and zip. A database table contains many records of data. A database table, perhaps named addresses, could contain hundreds, thousands, or more records. A quality database design is necessary for a high-performing database. A good database design begins with planning and careful attention to data integrity. A well-designed database facilitates data management and helps generate quality information. Poor database design causes slow response times, operational issues with software, and data errors that are difficult to trace. Data integrity is the accuracy and consistency of data. Data redundancy, when the same data is stored in more than one table, has a negative impact on data integrity. Risks resulting from data redundancy include inconsistent data, data entry errors, orphan records, and security concerns. When data is repeatedly stored, data can become inconsistent. For example, if a customer's email address is stored in the customer table and also in the address table, the data is redundant. If the email address changes, the customer table may be updated, while the address table is forgotten. The database now contains one correct email address and one outdated email address, causing a data inconsistency. Data redundancy may compound data entry errors. If the same data must be entered in more than one location, the probability for a data entry error is increased. Efficiency is decreased because of the time necessary to enter the data multiple times. Data anomalies may occur because of data redundancy. Orphan records, records that have no connection to other records in a database, may be caused by data redundancy. For example, a customer may be deleted from one table but inadvertently left in other tables. Data redundancy may heighten security risks. Data stored in multiple locations increases the possibility the data may be viewed or changed by unauthorized personnel. Data redundancy causes more challenges in controlling access to the data. Database systems can help with quality data storage. Data is stored logically in a single logical data repository. The data is physically distributed among multiple storage facilities. Database systems store data structures, relationships between structures, and access paths to the data. A database management system, DBMS, is a comprehensive software solution used to create, process, and administer databases. A database management system has many advantages. It provides a central location for data storage and querying capabilities so users have better access to data. A database management system has many built-in security features protecting the data from unauthorized access. It helps improve the quality of the data through features that limit data inconsistencies and promote quality data design. Popular database management systems include Microsoft Access, Microsoft SQL Server, Oracle, MySQL, and IBM DB2. These solutions include functionality for database storage, querying, monitoring, and backup. The database management system acts as an intermediary between the user and the database. It enables data to be shared. It presents the end user with an integrated view of the data. It receives and translates application requests into operations to fulfill those requests. And it hides the database's internal complexity from the application's programs and users. There are many types of database systems. The single-user database supports one user at a time. The desktop database runs on a PC. The multi-user database supports multiple users at the same time. The workgroup database supports a small number of users or a specific department, while the enterprise database supports many users across many departments. A centralized database, data is located at a single site. A distributed database, data is distributed across different sites. A cloud database is created and maintained using cloud data services, usually internet-based, and it provides defined performance measurements for the database. General-purpose databases contain a wide variety of data used in multiple disciplines, while discipline-specific databases contain data focused on a specific subject area. Operational databases are designed to support a company's day-to-day operations. Analytical databases store historical data and business metrics used exclusively for tactical or strategic decision-making. Online analytical processing databases enable retrieving, processing, and modeling data from a data warehouse. Business intelligence database captures and processes business data to generate information that support decision-making. Unstructured data databases keep data in their original state, while structured data has data that has been formatted. Semi-structured data has been processed to some extent. Extensible markup language XML databases represent data elements in a textual format. Next, we will use the Microsoft Access database management system to demonstrate some features of a database. Using the Microsoft Access database management system, I will demonstrate some of the concepts we have been discussing this week. We have been discussing the table and the field and records. In this database, I have two tables, customer and realtor. I'm going to first open the customer table in Datasheet View. In this view, you can see the fields and the data. Customer name is a field, phone is a field, address is a field, zip is a field. This set of fields for Alfred is a record, and this entire collection of records makes up the customer table. I have the customer table. I'm going to close that one, and I also have the realtor table. Realtor name is a field, realtor phone, realtor address, realtor zip. This collection of fields for Alex is a record, and these three records together have created the realtor table. Now this is the data sheet view of the table. There is another view. If you click here, you'll see there is the design view. In design view, you will see the field name as well as the data type. Text, number, date and time, and so on. Then for each field, there are a set of properties here listed at the bottom, including whether the field is required, whether the field has been indexed, the length of the field, and notice here the key symbol. The key symbol to the left of a field denotes the primary key, and here on the toolbar, primary key is pressed in. You can toggle between the two views using this button. Another important view for you this week in completing your assignment will be the relationships view. It will show how the data is connected. Here's the realtor table, the customer table, The key is also noted here. The fields are also shown here, and the relationship between the two tables. This is a one-to-many relationship. If you double-click directly on the line, you will have more information about the relationship between the two tables. So to summarize, these views will assist you with the assignment for this week. You can view your customers, the realtor table. You can view both in Design View. You can view information about each field, including their properties. You can view the relationships, and you can click on the relationship to view more about the relationship, including what type of relationship it is.